Welcome to today's Explainer. I am seriously so thrilled you're here because we are about to go on an epic, mind-bending journey together. Just imagine a time when there were no oceans, no mountains, no forests, absolutely zero life. A time when the literal ground beneath your feet didn't even exist yet. Today, we're traveling back through 13.8 billion years of history to unpack the complete, awe-inspiring story of how Earth was actually made. Let's get right into it.
Okay, let's dive into this. Every atom in our bodies was once forged in the heart of a dying star. Before Earth could even exist, the universe had to create the building blocks. Deep inside ancient stars, nuclear fusion was busy cooking up elements like carbon, oxygen, iron, the whole shebang. And when those massive stars eventually died in these spectacular supernova explosions, they just blasted those elements all across space. So we are, quite literally, made of stardust. It's just a wildly profound connection between ancient cosmic explosions and our very existence right now.
Which brings us to the ultimate question driving today's Explainer. How exactly did a lifeless, fiery rock become a living planet? Earth is currently the only known planet in the universe that supports life, right? It's home to more than 8 billion humans and countless other species. But honestly, that outcome was absolutely not guaranteed. As we're going to see, Earth's evolution is literally the ultimate survival story against totally insurmountable odds.
Chapter 1: Cosmic Origins.
It's honestly almost impossible for the human brain to wrap around the scale of time we're talking about here. So, 13.8 billion years ago, the universe is born in the Big Bang, expanding outward from this unimaginably hot, dense state. Then, we fast-forward billions of years in the dark to about 4.6 billion years ago, where this giant cloud of gas and dust, a solar nebula, collapses and ignites to form our sun. And finally, around 4.5 billion years ago, all that leftover cosmic dust begins to actually take the shape of our home.
But how does dust actually become a whole planet? Well, it happens through a process called accretion. Basically, this is where orbiting dust and rock particles continuously stick together, grain by grain, rock by rock, eventually forming these massive planetesimal building blocks called planetesimals. And listen, it wasn't some gentle gathering of dust. No, it was just countless rocky bodies violently slamming into each other in an extremely chaotic inner solar system. And that incredible violence leads us directly into our next phase.
Chapter 2: A Fiery Hellscape. So, as the young Earth accumulated more and more material, it got incredibly hot. We're talking heat generated by constant, daily asteroid impacts, intense radioactive decay, and massive gravitational compression. Talk about literally the worst possible vacation destination, right? These extreme forces basically turned Earth into this vast ocean of boiling liquid rock. There were absolutely no continents, no oceans, and definitely no atmosphere that could support life. But surprisingly enough, keeping the planet in this completely molten state was actually a crucial, absolutely necessary step for its future.
You might be wondering, why on Earth was that molten state so important? Well, because it allowed gravity to do its thing. While Earth was just this big ball of liquid rock, a process called planetary differentiation kicked in. Gravity pulled the heaviest elements, stuff like iron and nickel, sinking them all the way down to the center to form the solid inner core. Above that sits the liquid metal outer core. Then, the lighter materials kind of floated upward to form the really thick mantle of hot rock. And finally, the very lightest materials cooled off to form the super thin outer crust, which is where we live today. Gravity literally built the Earth from the inside out.
And just to give you a real sense of the sheer raw energy trapped inside our planet from that process, 5,000. That is the temperature in degrees Celsius of Earth's inner core right this very second. That's actually nearly as hot as the surface of the sun. It really just underscores the intense, ancient violence that's still locked deep inside our planet today.
Chapter 3: The Giant Impact. Now, with the planet all structured, you'd probably think things would finally settle down a bit, but get ready for a pretty catastrophic plot twist. About 4.5 billion years ago, a literal Mars-sized object named Theia slammed directly into Earth. The sheer scale of this collision it's almost unimaginable. It released way more energy than billions of nuclear bombs going off all at once. Huge chunks of rock and debris were just blasted out into space, and entire sections of the young Earth were completely vaporized, plunging it right back into a nearly entirely molten state. But out of that unbelievable destruction came something truly beautiful. That massive ring of hot debris surrounding Earth gradually started to merge together, getting pulled in by gravity to eventually form the moon. It's kind of a brilliant paradox, honestly.
massive, world-ending destruction directly created the exact conditions needed for life. Because you see, the moon isn't just pretty to look at in the night sky. Its gravitational pull actually stabilized Earth's really wobbly rotation and started influencing the ocean tides. It created this stable environment where life could eventually, finally take hold.
Chapter 4. Water and Bombardment.
So as the crust eventually cooled down, rain began to fall. And it fell for thousands, maybe even millions of years, slowly filling up the low-lying regions to create our very first primitive oceans. But then, right between 4.1 and 3.8 billion years ago, we enter this wild period called the Late Heavy Bombardment. Gigantic asteroids are just repeatedly striking the planet. Now, the absolutely crucial takeaway here is that while these massive asteroid strikes were literally vaporizing those early oceans all over again and totally reshaping the landscape, they paradoxically delivered the exact recipe needed for life. Those ancient space rocks brought fresh water, carbon compounds, and totally vital organic molecules right down from space.
Chapter 5. The Spark of Life.
With all those ingredients finally in the mixing bowl, somewhere roughly between 3.5 and 4 billion years ago, the very first tiny, microscopic organisms appeared. But there's just this incredibly stark juxtaposition between the world those first microbes lived in and our world today. I mean, the early atmosphere was thick, it was toxic, filled with sulfur and carbon dioxide, and it had absolutely zero oxygen. A human couldn't survive for a single second out there. Compare that to the modern, super breathable, oxygen-rich atmosphere that sustains us today. So how did we get from that poisonous, toxic cloud to the fresh air we breathe right now?
Well, the answer is entirely biological. It's a period called the Great Oxygenation Event. Basically, certain single-celled microorganisms evolved this remarkably neat trick, photosynthesis. They started using sunlight to convert all that thick carbon dioxide into energy, and they just burped out oxygen as a byproduct. Slowly but surely, the oxygen started to build up. This was a total biological revolution. Interestingly enough, it actually killed off a lot of the ancient oxygen-hating organisms that were already there. But it completely transformed the entire planet, paving the way for complex ecosystems, animals, and eventually us.
Chapter 6. An Ever-Changing World.
So life is evolving, but the planet itself wasn't just sitting still either. Earth's surface is constantly on the move, completely driven by the intense heat of that mantle we talked about earlier. 335 million. Just 335 million years ago, nearly all the land on Earth was smashed together into one massive supercontinent called Pangaea. Since then, those tectonic plates have drifted, broken apart, and slowly moved the continents into the exact positions we recognize today. It just goes to show that our current map of the world is really nothing more than a temporary snapshot. And it's amazing how these ancient, chaotic foundations now work together in perfect harmony to build this complete, totally protective system for us today. The tectonic plates are constantly recycling the crust and pushing up mountains. The molten liquid metal churning away in the outer core right this second is generating a massive magnetic field that acts like a giant invisible shield against deadly solar radiation. And those oceans, born from endless ancient rain and icy asteroid impacts, now perfectly regulate our entire global climate.
Earth really is not merely just a planet. Born from ancient stardust and shaped by billions of years of cosmic violence, it is hands down one of the universe's absolute greatest success stories. Every single ocean, every mountain, every forest, and every one of the 8 billion humans alive today is the direct result of a 13.8 billion-year journey of complete chaos, destruction, and ultimately, miraculous transformation. But remember, those tectonic plates, they're still drifting. The core is still burning hot. The story is definitely not over. Which leaves us with a totally fascinating, provocative thought to end our explainer on today. If fire, massive planetary collisions, and tiny little microbes could completely transform a lifeless rock into our vibrant, beautiful world over the last 4 billion years, what on earth will this planet look like a billion years from now? Thank you so much for exploring the genesis of a living world with me today. Keep asking those big questions, keep learning, and I'll catch you next time.